All right, here we go. Question number 16 from our Calculus 1, homework number 2 in WebAssign. It says, consider the following function. Here they've given me a piecewise function. And to start off with, they want us to find a couple of function values. So if we go to our scratch work, the first problem that they asked me to find is f of -1. And the way we're going to evaluate this is we're going to go to the test zone, the inequality section back here. I like to call that the test zone. And we're going to take our x and test it to see where to put it. So first question, is -1 less than -1? Is that true? No. And so then you move to the next inequality and you test there. So plugging in -1 for x, we would say, is -1 less than or equal to -1? And that is true. So this is what you do. So to calculate f of -1, we're simply going to replace x with -1 in the middle piece, and that's going to give us -2. Next, they want us to find f of 1. Again, going to the test zone, let's start here. Is 1 less than 1? No, that's false. And so moving to the bottom piece, we can say, is 1 greater than or equal to 1? Yes, that is true. So this is what you do. So to calculate f of 1, we're going to replace x with 1 in the bottom piece, and that's going to give us a 2. And so now that we know our first two answers, let's go ahead and input those. -2 and 2. And then what we can do is we can scroll up and see what else they want us to calculate. So next they want us to calculate the limit as x approaches -1 from the left, meaning that we're coming in from numbers that are smaller than -1. And that indicates that we need to refer to the top piece of the piecewise function, because that corresponds to x's that are less than -1. That would be coming in from the left. Since that is polynomial, to calculate the limit, we can simply do direct substitution. Replacing x with -1 is going to give us a 2, and so we know the limit as x approaches -1 from the left would be 2. And we can go ahead and fill that in for our WebAssign. And next, the only difference in the next limit is they want us to approach -1 from the right. So that would indicate that we're coming in from values above -1. In other words, the numbers would be greater than -1. And again, since this middle piece is polynomial, we can simply do direct substitution and calculate that limit. Replacing x with -1 is going to give us -2. And then we can input that into our WebAssign. Next part, they want us to find the limit as x approaches 1 from the left. Again, that means we're coming in towards 1 from numbers that are a little bit smaller than 1. In other words, numbers that are less than 1. So we want numbers that are less than 1. And again, that indicates we're going to be looking at this piece of the function. And again, since that's polynomial, we can do direct substitution to evaluate this limit. Replacing x with 1 tells us the limit will be 2. And then we can put that into our WebAssign. And again, the only difference for the next limit is they want to approach 1 from the right. Okay, so that means that we're going to be looking at numbers that are bigger than 1. Coming in from the right means that we're going to be using the bottom piece of this piecewise function. And since that's not going to give me an undefined, when I substitute, I can again evaluate to calculate this limit. Replacing x with 1 is going to give me a 2. And so the limit as x approaches 1 from the right should be 2. If we read the next part, it says find each x value at which f is discontinuous, and for each x value determine whether f is continuous from the right or from the left or neither. So the way we're going to do that is we're going to look at our limits. The first two limits were as x approaches -1 from the left and right. And if those are not the same, then we're going to have a discontinuity at -1. So we can input -1. That's going to be one of our x's where f is discontinuous. But the limit as x approaches 1 from the left and the right is the same. And so that would not be a point of discontinuity. Okay, so then for the next part, it wants to know if f is continuous from the right, left, or neither at this value of -1. And what that means is we need to go back and look at our piecewise function to see which piece of the function -1 actually goes in. And we can see the middle piece says x greater than or equal to -1. It's got the equal to part for -1. So that means that as we come in from the right, the graph will be continuous because it's included in that part of the function. That's where it would be continuous, where the -1 is actually allowed to be. And then if they want us to sketch the graph of the function, we know that there's going to be a discontinuity at -1, but coming in from the right has got to be a solid dot because it said -1 less than or equal to x. So it can't be this graph. Okay, it can't be this graph because it's not discontinuous at -1. There it's continuous. Okay, it can't be this graph, again, because it's continuous at -1. So hopefully the fourth graph will be the one we need. And that looks correct. Coming in from the left, -1's not allowed, but coming in from the right, -1 is allowed, and it is not continuous. And so we're going to select that. We're going to submit our answers and see how we did. And looking at all of our answer choices, including the graph, yes, it appears we got the green check of success for all of the parts. And so that's going to do it for this particular problem. If you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.